Okay, geometry kiddos, this is section 10.4. Again, new material, completely optional. Now we are talking about inscribed angles and how those are also used in intercepted arcs and polygons and that kind of thing. So let's go through some vocab here first. An inscribed angle is an angle whose vertex is on a circle and whose side contains chords of the circle. So for instance, if I have a circle, okay, if I draw, and I'm going to take it past the circle, but let me label these points A, B, and C here. Angle B is an inscribed angle. That's what we're talking about. Vertex is on a circle and whose sides contain chords of the circle. So we have chord BC and we have chord BA. All right. Now, the arc that lies in the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc of the angle. The intercepted arc would be arc AC. So arc AC is intercepted arc, okay? Angle B is inscribed angle. I could probably be more specific and say angle ABC maybe, but that's what we're talking about, okay? Inscribed angles and intercepted arcs. Now, theorem 7, the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Now, let me back up a little bit. We learned back in, I think it was 10.2, that an arc has the same measure of its central angle. A central angle comes from the center, okay? This is an inscribed angle. So an inscribed angle is 1/2 the measure of its intercepted arc. So if I said that this inscribed angle is, I don't know, let's say 30 degrees, okay? Then the arc would have to be 60 degrees. Okay, that's what theorem 7 is telling us, that the measure of an inscribed angle is 1/2 the measure of the intercepted arc. Okay, measure of angle B is 1/2 measure of arc AC. That's what theorem 7 is telling us. Now, if you remember, I don't want to muddy the waters here, but if you remember, if this were the center of our circle, okay, let me call that point D, then the measure of angle ADC stays 60. Central angles, not sure what I was doing here, ADC, central angles equal their arc measures, okay? Inscribed angles are 1/2 of their arc measures, okay? So just thought I'd throw that out there. I should have finished that one, so it's 30. Okay. Theorem 8, if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Now let me see if I can draw you a pretty picture for this one. So if I've got a circle here, and this is A, and this is B, okay? Let's say this is point C, this is point D. Now what they're saying here is that this angle is congruent to this one. How do we know that? Because they intercept the same arc. Okay, they intercept the same arc. So the measure of angle C is 1/2 the measure of arc AB. Okay, measure of angle C is 1/2 the measure of arc AB, and the measure of angle D is also 1/2 the measure of arc AB. They have the same, okay, they have the same intercepted arc. So that means that the angles must be congruent. Okay. Now, that next sentence says a polygon is an inscribed polygon if all of its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. So, in other words, let me do it over here on the other side. If I've got a circle, okay, and I've got some polygon, okay, I'm drawing a quadrilateral here. It could be any number of sides, okay. The polygon is called inscribed because it literally the sides lie inside the circle, and the circle that contains the vertices are circumscribed. So circumscribed is outside, okay? Okay, so circumscribed is the circle that's outside. Inscribed is, of course, the polygon where all the sides are inside the circle. So inscribed is kind of inside and circumscribed is outside. Theorem 9, if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Now think about what that means. So if we have a circle, okay, and I'm going to say that's my center, and that's my diameter, okay. First of all, this arc, if that's my diameter, this arc is 180 degrees, right? Well, its inscribed angle for that intercepted arc, okay, the inscribed angle for that intercepted arc would have to be half of that. So that would have to be 90 degrees, okay? That's where that comes in. So it says, conversely, if a side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. Okay, so that's what they're saying. Remember, okay, inscribed angles are half their intercepted arc measures. So a diameter obviously has an arc measure of 180 degrees. So that makes the inscribed angle with the same endpoints 90. Okay. Theorem 10, a quadrilateral can be inscribed in a circle if and only if, again, I want to point out the if and only if part here, okay? If and only if, remember that is biconditional statement, goes both directions. Its opposite angles are supplementary. Now, let me kind of show you or prove you a picture of this one. So let me start off with a new circle again, okay? Okay. Now that's a quadrilateral. I just put 4 points, 4 vertices on a circle. Now, first of all, if I draw, let me use different colors. If I draw this side, okay, this intercepted arc length, okay, this is 1/2 of that, right? And if I draw these, the opposite angle to that, this is 1/2 of that arc length. So let me label these. I'm just going to label this A, B, C, D. So what I could say then is that measure of angle A plus measure of angle C has to equal 1/2 of 360. Because would you agree that this blue arc, okay, that's the intercepted arc of angle A, and this red arc, which is the intercepted arc of angle C, obviously it forms a full circle, so it's 360 degrees. So the measure of those two angles, again, inscribed angles are half the arc length. So if I add up those, you get 360. Half of that is 180. So that's where this comes from. So measure of angle A plus measure of angle C equals 180 degrees. And of course, that is supplementary. Okay, I hope you all kind of see that. So if a quadrilateral is inscribed inside a circle, or if a circle is circumscribed about a quadrilateral, then opposite angles have to be supplementary. Because again, they have to add up to 180 because the arcs, the intercepted arcs, add up to 360. Okay, now let's use some of this. Let's look at their example 1. Use the inscribed angles to find the given measure. Okay, measure of arc YZ. Well, YZ here, okay, is this. Its inscribed angle is 50. You can clearly see that. So the arc is 100. Okay. Again, the inscribed angle is 1/2 the arc length. Now, measure of YWZ. So this one, measure of angle YWZ. So we're talking this angle here, YWZ. Well, this has the same intercepted arc as YZ. So if it's half of that, again, that means it's going to be 50. Okay, same intercepted arc. Okay, so we're going to use that same diagram now for 1 and 2. So let me erase the marks I put on in. So measure of arc WX, this arc right here, this arc WX. Well, look at its inscribed angle. Its inscribed angle is 35. Do you see the little arrow there? So remember, the inscribed angle is half the arc length. So that means the arc length is going to equal 2 times the inscribed angle measure. So that is 70 degrees. Okay, hope you see that. And then measure of angle WZX. Now, measure of angle WZX is this angle right here. Well, again, it is intercepting the same arc. So if this one is 35 degrees, then this one also has to be 35 degrees, okay? Or 1/2 of 70 degrees, okay? Because it's intercepting the same arc. Okay, next page. Okay, I'm not a huge fan here of example 2, so honestly, I think I'm going to kind of skip it along for the exercise for example 2. I'm going to run down here to theorem 10. Okay. Example 3, use theorem 10. Find the value of each variable. Now, let's remind ourselves what theorem 10 was. Theorem 10 said a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so quadrilateral just means 4 sides. Okay, so what this tells us is that, again, A plus C has to equal 180, and D plus B has to equal 180. Okay, so they set those up and solved. So let's look at our number 4 here. Okay, find the measure of each angle. Now, once again, let me do opposite angles here. This is an opposite angle to this. So that means that y plus 4y has to equal 180 degrees. Okay, so 5y equals 180. So y is 36. So this is 36 degrees. Down here, 4 times 36 degrees, or you could take 180 minus 36 degrees because you know it's supplementary. This would have to be 144 degrees. Okay, now let's look at the R and the P here. So I know that this angle, again, has to be supplementary to that angle. So I know that 3x plus 6x also has to equal 180. So 9x equals 180, x is 20. So then I plug it in. So over here, 3 times 20 is going to give me 60 degrees. And my P, 6 times 20, is going to give me 120 degrees. Those are all of my angle measures. Okay, and again, those should all add up, right, to what? Okay, those should all add up to 360. Okay, let's now practice A. Okay, find the indicated measure. Again, I'm just going to kind of randomly pick some out of here. Okay, remember, inscribed angles are half the arc measure. Okay, so measure of angle A, we're talking this one, measure of angle A. Here's the intercepted arc, okay, is 158. So measure of angle A is 1/2 158 degrees, which would give me 79 degrees. Okay, inscribed angle is half the intercepted arc measure. Okay, let's look at number 5. So number 5, we have this is 76 degrees, right? So we want the arc of BC, which is twice that then. Okay, twice 76 degrees is 152 degrees. Okay, again, inscribed angle is half the intercepted arc. And number 9, kind of doing the diagonal thing here. Measure of arc BC. Okay, now, measure of arc BC is what we're trying to find. Well, can I find the measure of angle A? I sure can, and here's why. First of all, this goes along with, what's the theorem number? Theorem 9, if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And that works for the converse as well. So since this is a diameter, okay, we have this diameter right here, that makes this angle 90 degrees. Okay, so that makes measure of angle A equal 180 minus 90 minus 64. Okay, I hope you guys are with me, which is 26 degrees. So that's measure of angle A. Now we need, so this right here is 26 degrees. So that makes this intercepted arc of BC twice that. So measure of arc BC is twice the inscribed angle, which is 52 degrees. I hope that made sense. Okay, again, if you have a triangle that the hypotenuse, well, it's going to have to be the hypotenuse is the diameter, then it is a right triangle. I should have just said if the longest side is the diameter, which it would have to be, then it has to be a right triangle, which would also make it the hypotenuse. Okay, 10 through 17, I'm just going to do the first couple. Find the indicated measure of circle M. So I need the measure of angle PNO. So we're looking at this one, measure of angle PNO. Well, if this is 68 degrees, okay, then this is half of that, right? So it should be 1/2 of 68 degrees, which is 34 degrees. Okay, I hope that makes sense. Now, the measure of angle QNP. Now, these are not necessarily congruent, okay? Now, what I do know is that PN is the diameter. I do know that PN is the diameter. Now, if that's a diameter, that makes this whole arc measure 180, right? So then can I use that information then to find the arc length of QP? Okay, So the measure of arc length QP is 180 minus 118, okay, which makes it 62. So this arc length is 62 degrees. So then how do I find the measure of the angle QNP? So this is 1/2 of 62, which is 31 degrees. I hope that makes sense. Okay, I know they kind of look like they might be similar or equivalent there, but they are not. Okay, this angle is not congruent to that angle. Not the same thing. Okay, moving down. Name two pairs of congruent angles. So if this is my arc length, remember my intercepted arc comes from two different inscribed angles. That means those inscribed angles have to be congruent. So that means this has to be congruent to that. So angle D is congruent to angle C. And if I look at it kind of the other way, okay, DC means that this angle is going to have to be congruent to that angle. So, because they're inscribed angles that are intercepting the same arc. So that means angle E is going to be congruent to angle F. Okay? All right, let's look at the backside. Decide whether a circle can be circumscribed about the quadrilateral. Now remember, we had that theorem 10, I believe it was 10. Yep, a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So a quadrilateral being inscribed is the same thing as saying the circle is being circumscribed around it. Okay, so what we're looking for is opposite angles right off the bat. These are opposite angles. If I add those together, I get 200. That's a big fat no. Okay, that is not supplementary. Okay, not supplementary. Now, moving on to the next section here. Find the values of the variables. Now, we just have to know that opposite angles, again, that's a quadrilateral inscribed in a circle or a circle circumscribed about a quadrilateral, depending on how you want to say it. So I know that x plus 62 equals 180. Okay, opposite angles, remember, have to be supplementary. So that means x equals 118. Same thing with y. Y plus 62 also equals 180. So y is also 118. If I know that, then you know what I can also say? I can also say that these are parallel. This is a trapezoid. Base angles are congruent. Okay, for what it's worth. Okay, next one. Find the values of the variables. Okay, so first thing I see here is this x. This angle x, okay, is an inscribed angle for this intercepted arc. So I know that x is going to have to equal 1/2 the intercepted arc, which is 170 plus 40. Okay, I hope you guys see that. So 1/2 of 170 plus 40 is, of course, 1/2 of 210, which is 105. So if x is 105, how do I find y? Well, x and y have to be supplementary. So 105 degrees plus y equals 180, right? So that makes y 75 degrees. Okay, I hope you see that. Okay, let's look at 31. I think that's the last one I'm going to do. Find measure of angle A and measure of angle C. Okay, first of all, Measure of angle A and measure of angle C. So we know that this intercepted arc comes from this angle and this angle. So we know that 2x plus 8 has to equal 3x minus 24. Okay, that means then that x equals 32. Okay, now if x is 32, then we need to find measure of angle C. Okay, so measure of angle C equals 2 times 32 plus 8, which is 72 degrees. That's C. Now, A, how do I get angle A? Well, this right here is 45 degrees. Okay, so this angle is going to have to be congruent to this angle because they intercept the same arc. Okay, so measure of angle A is also 45 degrees. Okay, all right, I hope that's helpful. That concludes section 10.4, using inscribed angles and polygons.